Welcome. In this training module, we will explore the core Azure Compute Services. We will compare virtual machines, containers, app services, and serverless functions to help you select the right infrastructure for your applications. Azure Compute Services provide the on-demand resources necessary to run your applications. Rather than buying physical hardware, you consume these resources as a service. To choose the right solution, you must understand the different hosting models available. We categorize these into three main buckets: Infrastructure as a Service, or IaaS, represented by virtual machines; Platform as a Service, or PaaS, represented by App Service; and Serverless Computing, represented by Azure Functions. We will also look at containers, which bridge these worlds by offering lightweight, portable environments. Each option offers a different balance of control, flexibility, and management overhead. This mind map outlines the landscape we will traverse. At the center is Azure Compute. Branching out, we see IaaS, defined by virtual machines and OS control. Next is PaaS, exemplified by App Service, which focuses on managed hosting. Then we have containers, providing portability through services like Azure Kubernetes Service AKS and Azure Container Instances, ASI. Finally, we have serverless, where Azure Functions allow for purely event-driven architecture. Understanding these branches helps you map your business needs to the correct technology. Let's start with virtual machines, or VM. A VM provides infrastructure as a service, IaaS, giving you a virtualized server that behaves just like a physical computer. The primary benefit here is total control. You have full access to the operating system, allowing you to install custom software, configure networking exactly how you want, and manage security settings. This makes VMs the ideal choice for lift and shift scenarios, where you migrate an on-premises application to the cloud without rewriting code. However, this control comes with responsibility. You are responsible for patching the OS and maintaining the environment. This diagram illustrates the IaaS model. At the bottom, the Azure platform manages the physical hardware and virtualizes resources like CPU and RAM. However, look at the top sections. The user, or admin, is directly responsible for configuring the operating system, highlighted in pink, and running the custom application. The boundary line is clear. Azure handles the metal, but you handle the machine. If VMs provide a full computer, containers provide just the application environment. A container packages your code and its dependencies into a lightweight unit that runs consistently anywhere. Unlike VMs, containers running on a single host share the operating system kernel, making them much more efficient and allowing for higher density. In Azure, you can use Azure Container Instances, ASI, to run a container quickly without provisioning any underlying servers. For complex, multi-container applications, Azure Kubernetes Service, AKS, provides an orchestration layer to manage scaling and deployment. Containers offer the ultimate portability between development, testing, and production environments. Here we visualize the efficiency of containers. At the base is the host with a shared OS kernel. Unlike VMs, which would each need their own kernel, container and container B sit directly on top of the shared kernel. Each container holds only the specific app and libraries it needs. This structure demonstrates why containers are lightweight and start up much faster than full virtual machines. Moving up the abstraction ladder, we have Azure App Service. This is a platform as a service, PaaS, offering designed specifically for hosting web and mobile applications. With App Service, you don't care about the server or the operating system updates. Azure handles all of that maintenance for you. Your focus shifts entirely to your application code and data. It supports various languages like .NET, Java, and Node.js, and includes powerful built-in features like auto-scaling and load balancing. This is the best choice when you want to deploy a web application quickly and don't need deep access to the underlying OS infrastructure. Finally, we have Azure Functions, which represents serverless computing. Serverless doesn't mean there are no servers. It means the servers are abstracted away so completely that you never think about them. Azure Functions are event-driven. Code runs only when triggered by an event, such as an HTTP request, a timer, or a message arriving in a queue. The major advantage here is the cost model. Unlike VMs or App Service where you pay for reserved capacity, with Functions, you pay only for the exact milliseconds your code executes. If no events occur, you pay nothing. This is ideal for background tasks and sporadic workloads. This sequence diagram captures the serverless lifecycle. An event source sends a trigger to the Azure function. The function activates only to execute code. Crucially, as soon as it finishes, it deactivates. The billing participant records usage only during that brief active window. The note at the bottom confirms that when the function is idle, There is zero cost. To summarize the comparison, think of these options as a spectrum of control versus convenience. Virtual machines give you maximum control, but require high management effort for patching and networking. Containers offer high portability and density, perfect for microservices, but orchestration with AKS adds complexity. App Service strikes a balance, offering low management overhead for web apps so you can focus on coding. Finally, Azure Functions removes infrastructure management entirely, offering the most efficient cost model for event-driven tasks, but with less control over the runtime environment. This quadrant chart visualizes the trade-offs. In the top right, virtual machines score high on both control and management. Moving down and left, AKS reduces management slightly but retains high control. App Service sits lower, reducing management further. Finally, in the bottom left, Azure Functions offer the least management overhead, but also the least direct control over the infrastructure. How do you choose? If you need full OS control or are migrating legacy apps that require specific OS configurations, choose virtual machines. If you are building microservices that need to run anywhere, choose containers. If your goal is simply to host a web application with minimal fuss, App Service is your best bet. And if you are running small pieces of code in response to events like processing a file, upload Azure Functions is the most efficient choice. Aligning your choice with these criteria ensures you optimize for both performance and cost. This final flowchart provides a decision matrix. Start at the top. Do you need OS control? If yes, go to virtual machines. If no, ask if it's a web or mobile app. If yes, use App Service. If no, ask if it's event-driven. If yes, use Azure Functions. If none of these apply and you need general workload orchestration, containers or AKS are likely your solution.